This lesson is titled Graphing, Square Root, and Other Radical Functions. Describe the graph of each type of function. Let's see, this first function looks like a horizontal line, so it's a linear graph, a simple linear graph. This next one is not a vertical line, but a diagonal line, another simple linear graph, y equals mx plus b. Here's a parabola, y equals x squared minus, looks like minus 2. Here's a cubic, that's y equals x cubed. Here's a square root, y equals root x. Here's a absolute value, y equals absolute value of x. And here's a reciprocal function, y equals 1 over x. So let's go ahead and write these so you can get to know these types of functions. So again, this is just a simple linear function, y equals some number. This is linear y equals mx plus b, where you can see the slope and the intercept. This is y equals x squared, but it's been shifted down by some value, looks like 2. This is y equals x cubed. This is y equals root x. This is y equals absolute value of x. And this last one is y equals 1 over x. That's not very good equals. So notice the shape of the graph will kind of tell you what you're looking at. The linear graphs have linear equations. The parabolas have quadratic equations. These stretchy S kinds of things, those are cubics. These kind of swoosh type things, those are square roots. The V's we've seen before, we've graphed a bunch of those too. Those are absolute values. And this one might be new, the reciprocal function 1 over x looks like this. So something to make note of here. Alright, graphing square root and cube root functions. Let's take a look at the graphs of the following functions. The first one, the square root, and the other one, the cube root. So the square root. If we're going to graph these, we can always make a table of values to get us started. So we'll start with x and then f of x. So for the square root function, we can't plug negative values of x in, so we're just looking at positive values of x. We'll look at 0, 1, 4, and 9. The square root of 0 is 0. So that'll give us the point 0, 0. The square root of 1 is 1. The square root of 4 is 2, and the square root of 9 is 3. That'll give us a few points to take a look at here. And if we start connecting the dots, we'll get a graph that looks something like that. It's a little hard to line these up perfect in PowerPoint, but that's close. The cube root, if we do the same thing when we make our table of values, we can actually have some positives and some negatives because we can take the square root of a negative number. So we get these values of points. And notice it has kind of a different looking shape here. It's a little bit like the x cubed we saw on this other slide, but notice how it's kind of been flipped a little bit. Flipped, and it almost looks rotated, but if you look real closely at the other graph, it's really not rotated. It's good to know that if you don't know how to graph something, you just start making a table of points, and then pretty soon a shape will appear when you start transferring those points to a graph. So let's look, f of x equals root x. We just had that graph, it looks like this. What about f of x equals root x minus 3? What should happen there? Think about what we learned when we graphed absolute values earlier, or when we graphed parabolas earlier. What should that minus 3 do? It's actually going to move the graph to the right. It's the same shape graph, it's just moved to the right 3. How about x plus 4? That's going to move to the left 4 off of the 0. And then x plus 8, that'll move to the left 8 from 0. So notice that number inside there will translate the graph left or right in the opposite direction that the sign says. In other words, in a direction you don't expect. You would expect plus 8 to go right, but it actually goes left. So it translates left and right in a direction we don't expect. Let's take a look at these. Here's our f of x equals root x again. What happens if I put a plus 2 outside? Remember your parabolas and your absolute values, it does the same thing. It'll shift it up 2. So it's the same graph, we just take that that kind of starting point at 0, 0, and we shift it up to 0, 2. What about minus 4? Well, that should take us down 4. Kind of makes sense. And then how about plus 5? Well, of course, that'll take us up 5. So that value on the outside will translate us up and down in the direction we do expect. So up and down goes the way it looks. Left and right goes in the direction we don't expect. So in this example, we're going to graph f of x equals root x plus 2 and then plus 3. So one thing to note is that this graph is going to be a shift of f of x equals root x. It should go to the left 2 and up 3. That'll put us at the point negative 2 comma 3. So when we go to make our table of values, it's good to know that negative 2 comma 3 is a really key point in this graph. And since it's just a square root function, it's going to take off in the general square root shape. It might be good to find the point when x is 0 here. When x is 0, we get root 2 plus 3. Root 2 plus 3 is looking like that's pretty close to 4. Well, root 2 is about 1.4-ish, and plus 3 is about 4.4. So our graph is a little off, but it's good enough for sketch work, I guess. Study the graphs of the following cube root functions. So f of x equals cube root x. Remember what that looks like? It's kind of this funny looking thing that snakes through the origin there. And if we subtract 3 on the inside, what should that do? It's going to do the same as all the other graphs that subtract 3 in the inside the major function part. It's going to go to the right 3. If we add 4, we're going to go to the left 4. And if we subtract 8, we should go to the right 8. So there's no change in that left and right translation. It happens for parabolas, it happens for absolute values, it happens for square roots, it happens for cube roots, it happens for everything. So left and right in the direction we don't expect. If we add or subtract on the outside, we get that vertical translation up and down. So minus 3 will go down 3, plus 4 will go up 4, and minus 8 will go down 8. So the translation on the outside is up and down in the direction that the sign says. In this example, we're going to graph a cube root function. Notice that the key point here is going to be negative 2, 1. So when we make our table of values, if we make one here, we want to make sure we include negative 2, 1. And since it's a cube root function, we kind of know the basic shape. Again, it might be good to know exactly what happens when x is 0. When x is 0, I get the cube root of 2, pretty small number, plus 1. It's more than 1 though, so this should be a little higher than 2. It looks like it is. Note that if x is negative 3, negative 3 plus 2 is negative 1, the cube root is negative 1, plus 1 is 0. So negative 3 is 0. Looks pretty good here also. In this example, we're going to graph x plus 3 to the 1/3 plus 1. We've been learning that that's the same thing as the cube root of x plus 3. And if we make a table of values, we're going to want a key point here at negative 3 comma 1. So let's make sure that our table of values has the point negative 3 comma 1. And then we want to check some points to the left and right of that. So negative 3 comma 1, if we're going to check points to the left and right of that, so we might check at negative 4 and negative 5, negative 2, negative 1, 0, and 1. That'll check to the left and right of negative 3 comma 1. If x is negative 5 and we use a calculator, we'll get approximately negative 0.4 for the y value. So negative 5 plus 3 is negative 2. The cube root plus 1 is approximately negative 0.4. If we check negative 2, it looks like that one comes out even. Let's try that in our head. Negative 2 plus 3 is 1. Cube root of that is 1. 1 plus 1 is 2. That's how they get the 2. If we go ahead and just plot all these points, and remember that that negative 3 comma 1 is the key point. That's where we're going to see the little change in direction, if you will, of the shape of the graph. It looks something like this. Here's another example. We're going to sketch the graph of y equals negative root x plus 2. So let's take a look here and see if we can determine a key point. It looks like a key point would be at, let's see, this is going to shift to the left 2, and there's no shift up and down, so it'll be at negative 2 comma 0. So if I'm going to do a table of points here, my x's and y's, I'm going to make sure I look at what's going on at negative 2, comma 0. I probably also want to look at what's happening at 0 and maybe at 2 on this side of negative 2. On the other side of negative 2, there's not I can't put anything else in there on the other side, can I? Because if I put in any negative numbers like negative 3 plus 2 is negative, and I can't take the square root of that, so I'm not going to be able to look at any of these numbers. Let's see, I could plug in a 7 and get a number I could do in my head. So let's try these values and see what we get. We have got, let's see, negative 2, 0 is right here. If I plug in 0, I get negative root 2, which is about negative 1.4. So somewhere in this area right here. If I plug in 2, I get 2 plus 2 is 4. The square root of that's 2, but there's a negative outside, so I get negative 2. So 2 negative 2 is about right here. And if I plug in 7, 7 plus 2 is 9. The square root of that is 3, which is about right here. And then I would just go ahead and draw the shape, but I've actually got it set up where the software is going to do that for us. So let's go ahead and do that. Let's have that software draw the shape for us. There it is. Let's bring back the table and the points we had, and actually we said this was going to be a 3, and that software went pretty much right through the points we had picked out. So we had a pretty good idea of where that graph was going, even compared to the graphing calculator there. Here's one for you to try. Go ahead and pause the video, give this a try, graph that that cube root function. And then when you're ready to check yours with the software that generates here, press play. All right, let's make a table of values. We've got our x's, we've got our y's. Looks like a key point's going to be at negative 1, comma 3. A good point to check would be 0, because that'll come out nice and easy. Let's see. There's no other really good points to check here except for maybe 7 on this end. Back here, if we check negative 2, that would be a good one to check. And negative 9 would be a good one to check. So let's see what we get. If I plug in 0, let's do the easy ones first. I get 1, cube root is 1, minus 3 is negative 2. If I plug in 7, I get 8, cube root that's 2. Notice how I pick numbers that give me nice cube roots that come out nice here. 7 plus 1 is 8, cube root that's 2, minus 3 is negative 1. You can do that too. You get to pick these numbers, so you might as well pick ones that work easily in here so you don't have to pick up a calculator so much. If I pick negative 2, negative 2 plus 1 is negative 1, cube root of negative 1 is negative 1, minus 3 is negative 4. And then negative 9 plus 8 is negative 8, cube root's negative 2, minus 3 is negative 5. So this gives me a bunch of points to check. Negative 1, 3, that's an important key point. 1, 2, 3, let's make sure we get that graphed. Make that one a little bigger so I can find it when I'm trying to make sure I've got the middle. Negative 2, negative 4, negative 2, negative 4. Ooh, I didn't draw that first one right, did I? Let's fix that. I hate it when I make errors like that, but that's a pretty bad error. So let's catch that. Negative, oh wait a minute, negative 1, 3 was right. I was looking at a different point when I thought that was an error. 1, 2, 3. Okay. Negative 1, 3. Let's go back here. Negative 1, I hate it when that happens. Negative 1, 1, 2, 3. Alright, so negative 9, negative 5. Negative 9, negative 5. 1, 2, 3, 4, 5 down here. Negative 2, negative 4. 2, 1, 2, 3, 4 down here. 0, negative 2. 0, negative 2. 1, 2. Something is not looking right at all here. 7, negative 1. Let's check these. Negative 9. If I put negative 9, I get negative 2. That's 5. How did I get? Oh, that's what it is. That's negative. Holy cow, how did I miss that? So you could see something was goofy in the graph here. That point's just way out of line right there. So let's fix that point. If you know what the graph is supposed to look like, then when you do a silly mistake like that, you can catch it. So -1, -3, -1, -1, 2, 3. That makes way more sense. Now you can see the shape that's going to come through here. Hit that and kind of turn the other way. Again, if we let the software do the graphing here, and then we can bring our points and our table back. And notice how the graph goes pretty much right through the points, and we do have that turning or that change in, we're going to call this concavity in a couple of years, but we have that change in concavity here. So good job. Knowing what the graph is supposed to look like actually saved a huge little arithmetic or interpretation mistake here. Here's another one for you to try. Go ahead and pause the video and give this a shot. If I was doing this, I would rewrite this as y is equal to the negative cube root of x plus 4, and then way out here plus 6, because that's kind of the format I expect. So I know there's a key point at -4, 6. This is a positive 6. You could see it here too, and if you don't want to rewrite, if you just want to realize that's the up and down that we normally see on the end, that's okay too. Let's go ahead and do our table of values so we get an idea of what's going on here. We've got a key point at -4, 6, and we need to find some values that are easy to get cube roots out of. Let's see, if I have -3, that'd give me a good value. It looks like 4 would give me a good value. I need something on the other side here. Let's go -5. And the next good value is not till like -12, which isn't going to fit on my graph. So let's see if we can get it with these points. -5. -5 plus 4 is -1. Cube root is -1. So it's 6 minus -1 would be 7. Let's try -3. -3 plus 1 is 1. Cube root is 1. 6 minus 1 is 5. And when I put in 4, I get 8. Cube root, that's 2. 6 minus 2 is 4. So let's plot points. And my key point, -4, 6. 1, 2, 3, 4, 5, 6 right here. That's going to be where it turns. And I should have a -5, 7. I should have a -3, 5. And a 4, 4. 1, 2, 3, 4. So this is, it's going to turn and stay fairly flat. So it's going to kind of mirror that flatness up here. It's going to look something like that coming through here. So again, let's let the software graph that. And then we'll bring our points and table back and see how close we came there. Bingo, right on the dots again. How'd you do? That's our learning target for this lesson. I'll see you in class.